The 220.20 demand factor only applies to kitchen equipment. Water heaters are typically not considered kitchen equipment unless they are specifically installed for use as a kitchen appliance. Therefore, the water heater cannot be included in the 220.20 demand factor unless it is specifically identified as kitchen equipment in the calculation. Cord and plug connected equipment such as microwaves, refrigerators, freezers, and mixers can be considered kitchen equipment for the purpose of 220.20 if they are used for food preparation or storage. This includes appliances that are permanently installed, such as built-in microwaves and refrigerators. However, appliances that are not used for food preparation or storage, such as space heaters or fans, are not considered kitchen equipment. To further elaborate on the application of the 220.20 demand factor and its relevance to various appliances, let's delve deeper into the specifics. Firstly, it's essential to understand the core principle behind demand factors in electrical load calculations. Demand factors are used to account for the fact that not all electrical equipment in a building will operate at its maximum rated load simultaneously. This allows for a more accurate and cost-effective determination of the overall electrical service size required. The 220.20 demand factor specifically pertains to kitchen equipment in commercial settings. The National Electrical Code, or NEC, provides guidelines on how to apply demand factors to various types of loads. The intent behind the 220.20 demand factor is to recognize that in commercial kitchens, multiple appliances may be present, but they are unlikely to all operate at their full capacity at the same time. Now, addressing the question of water heaters, it's crucial to differentiate between water heaters used exclusively for kitchen purposes and those serving other functions within the building. A water heater dedicated to supplying hot water to dishwashers, sinks used for food preparation, or other kitchen-specific needs can potentially be included under the 220.20 demand factor. However, a water heater that also provides hot water to restrooms, cleaning facilities, or other non-kitchen areas should not be considered part of the kitchen equipment load for the purpose of this demand factor. To determine whether a water heater qualifies, consider its primary function and its physical location in relation to the kitchen area. If the water heater is located within or immediately adjacent to the kitchen and serves only kitchen equipment, it's more likely to be eligible for the 220.20 demand factor. Documentation may be necessary to support this determination, such as plumbing diagrams or equipment schedules that clearly indicate the water heater's intended use. Regarding cord and plug connected appliances, the NEC generally considers appliances used for food preparation or storage as kitchen equipment. This includes microwaves, refrigerators, freezers, mixers, blenders, and other similar devices. The key factor is whether the appliance is directly involved in the process of preparing or storing food. For example, a microwave used to heat up meals for employees in a break room would be considered kitchen equipment, whereas a space heater used to warm the same break room would not. Similarly, a refrigerator used to store ingredients in a commercial kitchen would fall under the 220.20 demand factor, while a refrigerator used to store beverages in an office area would not. It's important to note that permanently installed appliances, such as built-in microwaves and refrigerators, are also subject to the same criteria. If a built-in microwave is used for food preparation in a commercial kitchen, it can be included in the 220.20 calculation. Conversely, if a built-in refrigerator is used for non-kitchen purposes, it should not be included. When performing load calculations, it's essential to gather accurate information about the connected load of each appliance. This information can typically be found on the appliance's nameplate, which lists the voltage, amperage, and wattage ratings. Use this information to determine the total connected load of all kitchen equipment. Once the total connected load is determined, the appropriate demand factor from NEC Table 220.20 can be applied to arrive at the demand load for kitchen equipment. The demand factor will vary depending on the number of appliances and their combined load. It's also important to consult with local electrical inspectors or authorities having jurisdiction or to ensure compliance with local codes and interpretations. The AHJ may have specific requirements or guidelines regarding the application of demand factors to kitchen equipment. In summary, the 220.20 demand factor is a valuable tool for reducing the calculated load for kitchen equipment in commercial settings. However, it's crucial to apply the demand factor correctly, considering the specific use and location of each appliance. Water heaters should only be included if they are specifically dedicated to kitchen use, and cord and plug connected appliances should only be included if they are used for food preparation or storage. By following these guidelines and consulting with the AHJ, you can ensure accurate and compliant electrical load calculations. Furthermore, let's consider some practical examples to illustrate the application of the 220.20 demand factor. Imagine a small commercial kitchen with the following equipment: firstly, a 1.5 kilowatt microwave oven, secondly, a 2 kilowatt refrigerator, thirdly, a 3 kilowatt dishwasher, fourthly, a 4.5 kilowatt electric range, and fifthly, a 6 kilowatt water heater dedicated to the dishwasher. The total connected load of this kitchen equipment is 1.5 kilowatts plus 2 kilowatts plus 3 kilowatts plus 4.5 kilowatts plus 6 kilowatts, which equals 17 kilowatts. According to NEC Table 220.20, for a total connected load of 17 kilowatts, the demand factor is 0.65. Therefore, the demand load for the kitchen equipment is 17 kilowatts multiplied by 0.65, which equals 11.5 kilowatts. This means that instead of designing the electrical service for the full 17 kilowatts of connected load, you can design it for only 11.5 kilowatts, resulting in significant cost savings. Now, let's consider another example where the water heater is not dedicated to kitchen use. Suppose the same kitchen has the same equipment, but the 6 kilowatt water heater also supplies hot water to a restroom and a mop sink. In this case, the water heater should not be included in the 220.20 calculation. The total connected load of the kitchen equipment, excluding the water heater, is 1.5 kilowatts plus 2 kilowatts plus 3 kilowatts plus 4.5 kilowatts, which equals 11 kilowatts. According to NEC Table 220.20, for a total connected load of 11 kilowatts, the demand factor is 0.75. Therefore, the demand load for the kitchen equipment is 11 kilowatts multiplied by 0.75, which equals 8.25 kilowatts. In this scenario, the water heater would need to be calculated separately as a general use load, using the appropriate demand factors for water heaters. When determining whether an appliance is used for food preparation or storage, it's important to consider the appliance's intended purpose and its actual use. For example, a small refrigerator in an office break room might be used primarily to store employees' lunches and beverages. In this case, it could be argued that the refrigerator is not being used for food preparation or storage in the same way as a refrigerator in a commercial kitchen. However, the AHJ may have a different interpretation, so it's always best to consult with them. It's also important to consider the impact of energy-efficient appliances on load calculations. Energy-efficient appliances consume less power than their older counterparts, which can reduce the overall connected load. When replacing older appliances with energy-efficient models, be sure to update the load calculations accordingly. In addition to the 220.20 demand factor, there are other demand factors that may be applicable to commercial buildings. For example, NEC Table 220.42 provides demand factors for general lighting loads, and NEC Table 220.44 provides demand factors for receptacle loads. It's important to consider all applicable demand factors when performing a comprehensive load calculation. Furthermore, it's crucial to maintain accurate records of all load calculations and supporting documentation. This documentation should include appliance nameplate information, circuit schedules, and any other relevant data. These records can be helpful when troubleshooting electrical problems or when making changes to the electrical system in the future. Remember that electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest requirements. Regularly review the NEC and any local amendments to ensure compliance. In conclusion, understanding the application of demand factors is essential for accurate and cost-effective electrical load calculations. By carefully considering the use and location of each appliance and by consulting with the AHJ, you can ensure that your electrical system is properly sized and compliant with all applicable codes. Remember to differentiate between water heaters used exclusively for kitchen purposes and those serving other functions within the building. Cord and plug connected appliances should only be included if they are used for food preparation or storage. Maintain accurate records of all load calculations and stay up to date on the latest code requirements. By following these guidelines, you can ensure that your electrical system is safe, reliable, and efficient. It's also worth noting that some jurisdictions may have adopted energy codes that require the use of energy-efficient appliances and lighting. These energy codes may also impact load calculations and demand factors. Be sure to check with your local building department to determine if any energy codes are in effect in your area. In addition to demand factors, there are other factors that can affect the overall electrical load of a commercial building. These factors include the diversity of loads, the operating schedule of the building, and the climate. The diversity of loads refers to the variety of different types of electrical equipment in the building. A building with a diverse mix of loads, such as lighting, HVAC, and process equipment, will typically have a lower overall demand than a building with a more uniform load profile. The operating schedule of the building also affects the electrical load. A building that is only occupied during daytime hours will have a lower demand than a building that is occupied 24 hours a day. The climate can also play a significant role in the electrical load. Buildings in hot climates will typically have higher cooling loads, while buildings in cold climates will have higher heating loads. When performing a load calculation, it's important to consider all of these factors to arrive at an accurate estimate of the building's electrical demand. Finally, it's important to remember that electrical work should only be performed by qualified and licensed electricians. Electrical systems can be dangerous, and improper installation or maintenance can lead to serious injury or death. Always hire a qualified electrician to perform any electrical work in your home or business. In addition to the points already discussed, it's vital to emphasize the significance of accurate documentation throughout the load calculation process. Comprehensive documentation serves as a valuable resource for future reference, troubleshooting, and potential modifications to the electrical system. Firstly, detailed records of all appliances and equipment included in a load calculation should be maintained. This includes nameplate information such as voltage, amperage, wattage, and any relevant motor horsepower ratings. Secondly, circuit schedules should be meticulously prepared, clearly indicating the loads connected to each circuit breaker. This helps in identifying potential overloads and ensuring proper circuit protection. Thirdly, any assumptions or engineering judgments made during the load calculation should be clearly documented. For example, if a specific demand factor is applied based on the anticipated usage patterns of certain equipment, the rationale behind this decision should be recorded. Fourthly, copies of all relevant electrical plans, specifications, and permits should be readily available. These documents provide a comprehensive overview of the electrical system and its design. Fifthly, regular updates to the documentation should be performed whenever changes are made to the electrical system. This ensures that the records accurately reflect the current configuration of the system. Sixthly, it's beneficial to utilize software tools designed for electrical load calculations and documentation. These tools can streamline the process, improve accuracy, and facilitate the generation of reports and other documentation. Seventhly, consider consulting with a qualified electrical engineer to review and validate the load calculations and documentation. An engineer can provide an independent assessment of the system's design and ensure compliance with applicable codes and standards. Eighthly, proper labeling of electrical panels and equipment is essential for safe operation and maintenance. Clear and accurate labels should identify the circuits, loads, and any other relevant information. Ninthly, conduct periodic inspections of the electrical system to identify any potential problems or discrepancies. This can help to prevent costly repairs and ensure the continued safe operation of the system. Tenthly, consider implementing a comprehensive maintenance program for the electrical system. This program should include regular testing, cleaning, and inspection of all components. By following these guidelines, you can ensure that your electrical system is properly documented, maintained, and operated. This will help to prevent costly problems, ensure safety, and prolong the lifespan of the system. Remember that electrical safety is paramount, and all work should be performed by qualified professionals in accordance with applicable codes and standards.